Welcome, everybody. We're going to be working on more Chapter 2 exercises this evening. And I am inside my Spider IDE, and I do plan to work on the regular exercises, which are exercises 5, 11, and 32. Those are the ones we're working on. And I am going to get my environment kind of all keyed in here. But I'm going to start with actually a little bit of a demo, and I'm not really even sure what to call this. I guess I'm going to call it maybe string demo or something like that. I am going to put it in my regular Python folder here for fall of 2024. And we are still in unit 2. And you know what? We have a unit 2 part 1 and a unit 2 part 2. I'm actually going to keep those in separate folders. So I'm actually going to rename my first unit 2 folder and call it part 1 to match the exercises. And then I'm going to create a new folder called unit 2 part 2. So all the stuff from this week will go into that folder. And then this one I'm going to call string demo. All right. So my goal in this one is really to talk a little bit about some of the techniques that we've been kind of just using, and haven't really talked a lot in depth about them. And I think in some ways the book maybe falls a little bit short in doing so as well. So we have, kind of as a recap, we've learned how to put stuff on the screen, right? And so we use the print function to basically do that. I can put whatever I want inside that print function. So I can put in a number. So if I run the number, it comes out on the screen. And I can use the print command to output some words. And we are talking about this during the Kahoot that we did earlier. These print statements contain literals, right? So we talked about what is the literal, right? So here, print is literally printing the number 9. It's not a stored value in a variable. It's the number 9. Here, this print statement is printing a literal string. It literally is the string. It's not stored in a variable. So some terminology, by the way. Another thing that we kind of learned how to do is we learned how to do input statements to capture information from the user. So for example, if I come up with a variable called username, and then I do an input statement prompting the user to, enter your username, right? And I might come up with a fancy looking prompt or whatever. And then I run that and capture it, right? I can type in whatever I want and it'll get captured. Now, I won't see it, of course, until I output that username. So for example, I might do a statement that says print welcome, and then I want to display the username also. So I'm going to put a comma, because normally if I was to do this, I'd say welcome, comma, person, and then with the way that the traditional concatenation works inside of Python, we normally do it like this. We do a comma, which also adds a space, and then we can append the username, which the user entered. I'm going to leave these statements here, but I'm going to run this code again, right? So enter your name, whatever, press enter, welcome, whatever. Okay, so that's using traditional concatenation. And once again, concatenation is the act of joining strings together. So I'm just going to drop that in as a comment. That's the most basic output for Python, concatenation, spelled correctly. There we go. Concatenation, or is it? Boy, now I'm questioning myself. Is it concatenation? Yeah, that's correct right there. That's concatenation. Concatenation literally means joining strings together. The traditional Python way to do it is with the comma. Not what you learn in other languages typically. There's another technique though, right? So you could also use the techniques that you've learned in other languages. So I could say instead, welcome, comma, space, here I have to add the space, And then afterwards, I can use the plus sign and say username. This is how we do it like in Java or JavaScript or C Sharp, for example. This is one way to do it. So, and real frankly, in most languages, when we're concatenating strings or joining strings, that's the typical approach. But the space in between has to be added manually, right? So let's do this again. Enter your name. I don't know. Brett Favre. Remember that guy? Yeah. But the output essentially is the same on the screen. Yeah. So that's the second technique. And we can call this maybe, I don't know, the old school multi-language concat approach. How about like that? Right, because that's kind of what it is. So if you're used to the like how Java does it or whatever, you can use that approach. It still works in Python. The new school way, and what we see a lot of people switching to now, and the book really doesn't talk about it a lot, is that string interpolation approach. So we put this letter F at the beginning, we still put in our double quotes, and then we still type in our message, right? We do add whatever spacing, and then instead of concatenating outside the double quotes, we instead put in a set of curly brackets and then add the variable name, and it's right inside the string. It's right inside the double quotes. This is called string interpolation, and I'll type that in before I run it. I know that's a really fancy word, but basically it allows for direct insertion of a variable into string output. So if I run that again, and who's the person now that I'm typing in? I don't know.
Aaron
Whomever. How about that? Right. Welcome whomever. But you see, ultimately, it doesn't matter which technique you use, they all work. If you want to experiment with these, please do. Right. And you know what? I think it's really helpful that you play with these. There are some limitations to each of them. So let me talk about that first. The first approach works fine with both letters and numbers. The second approach works only, and I want you to hear this really carefully, works only with strings. This concatenation symbol, if I throw a number in, it's confused. It doesn't know what it's doing. It's not sure if it's doing math or joining strings. So, so I'm going to say use only with strings. The last approach also works with numbers and strings and actually is pretty handy because of it. So, for example, let's do a blank line here, print line, and let's do another prompt. So I'm going to do user age. Right, so we're going to prompt the user again, and we're going to say input. How old are you? First question, is this being captured as a number or is it being captured as text? You guys recall this from last time?
text,
Yeah,
string,
yeah, correct. If anything that comes in from the keyboard, doesn't matter if they type a number or a word or a special character, it's all text. So if I take that output, by the way, and then I want to output it to the screen like this, right? And I run it. So now it's going to say username. I'm just typing nonsense. And now how old are you? And I put in, 34, which is true. It's going to output it as text. But what if I do a conversion? So you know what? Let's We haven't done this standalone yet. Let's just prompt again. I'm actually just going to change this. All right, so I'll just do an int conversion here and wrap parentheses around it. And then let's do it again. So username, how old are you? 45. That's more true, I guess, right? And it still works. So this, it just shows you that this one doesn't care if it's a number or a string. It converts it when it goes into this format. I like this format a lot. I guess it was the last time I did training on it was this winter. I did more Apple iOS app development training over the winter, some pretty advanced stuff. And string interpolation is all over that language, which is Apple Swift, by the way. It's their kind of like a hot wired version of C, you know, and it's kind of Python like, it's kind of JavaScript like, it's kind of C like, really cool language. And they try to do everything with string interpolation. It's so cool and powerful, by the way. So I think that does a pretty good example of like those output statements. Here's a little bit more code. I'm going to drop this in kind of a rapid fashion here. So I might have a variable called X that contains the number 5 and a variable called name that contains my favorite, whatever, right? And then I might go ahead and do an output. So this is just kind of practice. I'm not sure where that came from. Right. So we're going to print the name and the number. So just to demonstrate that we can do that again. So let's just do that. Username, age, right? And then here's the other thing that we have here. Whatever and 5. So that's working, right? If I take that a little bit further, right? A couple little things that we can learn to do with strings too. So this will be kind of peppered into some of our discussions here, but there are what we call functions that are built into this language that allow you to do some really useful and weird kind of things, right? So one function that's really useful is the length function. The length function is basically the keyword len, a set of parentheses, right? Which tells us how long the string is. It counts how many letters there are, basically. And then we have the string function, which converts, okay, there's a typo. So what you get for copy pasting flawed stuff, which converts things to text for output. So this is kind of like a weird kind of thought, but I'll demo all this so you can see what I mean by it. So the first little demo is this one. And I'm just going to put the statement on the screen and then we can kind of backwards engineer it. So your name is, right? So what is this doing? It's checking the length of name, right? So whatever name I typed in, right? In this case, whatever. So that's 8 letters. And then it's taking that number 8 and it's converting it to a string. So we have a function inside of a function. And because I can print 2 strings together, it'll say your name is 8 letters long. Let's try it. Here we go. Username, that one's kind of moot. How old are you? 12, 22, whatever. All right. Your name is 8 letters long. All right. Here's a second example of that statement done a different way. And so once again, what I'm really trying to do here is kind of demonstrate the 3 different output techniques, kind of mixing a bunch of different techniques. So with this one, the old school Python concatenation comma approach, I don't need to convert the number that's going to generate the number 8, right? And then the third way with string interpolation, let's see if I can get it copied here from my other screen, you know, with the F string approach, where that length function can go inside those curly brackets and we functionally get all the same stuff. So all of them generate the same output. So that's another example. Another thing that we're going to learn about too, and also utilize, and this is one of the powers of Python, frankly, its ability to manipulate language like on a really deep level with very simple commands is one of the reasons why we use it for artificial intelligence. So we have functions that we can utilize, and functions, and I make this little note here, functions can also be called methods when they are part of a larger object, by the way, but we haven't learned that concept yet. We'll just call them functions for now. But for example, we can run commands such as this. I'm just going to drop them on the screen, right? Where we can take basically an object that we have created in memory. This is a variable, right? Username, the same username we're capturing up here, right? And then we can append to it using what we call dot notation. So in other words, this function is basically built into this class structure inside of Python called strings. Strings have a whole library of functions that go with them. And if you use dot notation, it really is indicating that we're using a string method, so it's built into a larger object. And this command would convert everything to uppercase. This command converts everything to lowercase. And this command capitalizes it. So watch, I'm going to run this now, and I'm going to put in a username starting with a lowercase letter, like Alan Pearson. I won't do that. We'll just say Alan. We're not picking on Alan, right? So I know you software people think that's funny. So we're going to ask how old, and of course, 11, right? But notice uppercase, all uppercase letters, all lowercase letters, didn't change anything because it already was. And then capitalized with just the first letter being capital, even though the user didn't put that in. Now you're wondering, okay, why is he showing us all this stuff? Well, the one thing that is important is to understand that there are basically 3 different string concatenation methods, right? The comma approach, that's the one the book shows. There's the old string joining approach, but it can be used only with strings. And then there's string interpolation, which is where we put the letter F at the beginning. And then we use curly brackets to insert the variable or whatever we're doing directly into the code inside of the double quotes. That's probably the more modern way. The other thing is some of the functions that we use, like uppercase, lowercase, capitalize, the length of a string, and the ability to take something and convert it to a string, those are all functions that are sometimes necessary to make our programs efficient and do the things we want. So just for example, like if you give a person a prompt that says, do you like green, or, do you like green? Yes or no. How do you know if they're going to type uppercase Y or lowercase y? You got to accommodate for both, right? You don't want to like send a message back going, hey, I was looking for a capital Y. That's not what you want to do. You just want to take the input they give you, convert it, and go with it, right? That's more user friendly. All right, so this is my string demo, folks, right? For anybody that's interested in this material, and provided it fits in the chat, I'm hoping, I'm just going to drop it in the chat for everybody, and you can just use it as reference, right? It looks like a fit. So there you go. There's my example. If you guys want to play with it, you have something you can draw from. And so maybe you find that helpful. Right, now we're going to move on to the exercises. And if I was smart here, and I'm hoping I was, right, I wasn't smart. I didn't put the instructions inside my solution file, so I do have to pull the book up on screen. So I'm going to just go through that process here really quickly. I'm going to go to Vital Source. That is where my book repository is.
Excuse me, can I ask a question about?
Absolutely, please do.
What is the difference? I think we talked about this, basic versus, I forget. Anyways, what is the difference between a function such as str or alien that you normally prepend? Compare that to what you just showed us, the dot notation functions, dot capitalized, uppercase or upcase or whatever and lowercase or capital, yeah, capitalized uppercase. Those three variations. What
I
were you?
think,
What is the name? What are the names of? How do you
yeah,
distinguish with the name? With the name? Yeah. Anyway,
that's a really
yeah.
good question, actually. And really the distinction is this. When you see something and it's got a dot notation and it's appended to an object, that means it's technically a method, which is part of a larger class library, which is basically a collection of functions. So it exists because username is of type string, then it has the string class functions available to it as methods. And so it uses this notation.
Would
When
we
you see
have
a
used dot? Oh, sorry. Go ahead. Go
yeah,
ahead.
no, when you're looking at one that's like this, where it's a standalone function, that's part of the standard Python libraries. So I don't use dot notation to access it. I just use the function name. That would be the difference between them. Excellent question though, because these are questions people don't usually ask, Martin. Right. So it shows me that you're deeply thinking about it, which I appreciate.
Thank
Um,
you.
and the rest of you should think deeply about these things too. But they're actually kind of like they are deep questions, right? And I'll be real frank, like when I was first studying this stuff, a lot of that stuff didn't stick with me. I had to like do it for years and years and years to go, oh, that's what they mean. I knew how it worked, but I didn't know the definition. What Martin is asking is actually like, what's the definition? What does the definition really mean? So he's asking the deep question before we dive into the stuff. And you know what? The answer might make no sense to you. And you know what? That's okay. Right. It might come later, like it did for me. That doesn't mean you won't get it. Right? But maybe you will, and maybe it'll make your mind go. Right. So this first exercise that we're working on is a reboot of the exercise above. You guys remember we did the sum, the difference, the product, the average, and all that stuff, right? And so here's kind of a tip is you should go to your recent files and open up exercise 2.4. And I don't know if I have it on my list here. I guess I don't. So I'm going to have to go find it. Let's go find it. So open it up. Unit 2, part 1. Oh, can't find it because I changed the folder name. Aha. Right. Okay, so here's that program. And now I'm going to do a save as. It is going into a different folder, so I'm being really careful about that. So I'm going to put it in Unit 2, part 2 folder, and I'm going to call it exercise 2.5. The point is, most of the program is already written. Okay, so I don't want to recreate what I've already created. That's ridiculous. Right, so I'm just taking it as it was, and now we're going to ramp it up. And basically what we're going to do is what the book is asking, that basically instead of creating an output, so for example, let's run it and see what the output looks like. Oops. Oh, okay, there we go. I hit the history button there by mistake. So let's put in the number 2 and a number 3. And so this is what it looks like as an output. But it's not very pretty as an output at all, right? And what they want us to do is to make it look like this. Now, here's kind of one of the issues here. One of the issues is we can't predict what number the user or numbers the user is going to type in. They might type in little numbers like I did, like 2 and 3, or they might type in very large numbers, and I have to set it up so that they line up nicely regardless of what they type in. The other thing that I'm noticing is there's a potential that some numbers could be negative, that some numbers might have a decimal point with numbers following, and that I don't want those numbers to be on the line. So like right now, they're all over the place. Okay, so I'm glad I brought up the book because really the answer to how to do this, by the way, is in looking at some of the book content. And I'm going to try to find the page here where they talk about this. And so, I'm scrolling through the book really quick. I should have bookmarked it before, but hey, shows you how prepared I was. And that's quite all right. There's a a table here in one of the pages. Eventually, I shall find it. Yeah, I think I'm getting close now. This, by the way, is the book. All right, so this is the page I'm looking for. This is in section 2.5 in chapter 2. And when we learn to do, and if you remember from our Kahoot once again, that we talked about this, the percent dot 2f to format numbers so that we get, two decimal places, after the decimal point, right, with a floating point number. What's kind of interesting about these formatting commands, right, is that there's a whole bunch of other variations that we really didn't talk about last week. We just very quickly did the dollars and cents one and ignored all of these other ones. But yes, I'm going to talk about them today. So there are all these different formatting things, and this is part of what this exercise is about. So the one thing is that we can use different letters. So we can use D's, F's, and S's, and more percents, by the way. What the D's are for is basically to declare the fact that we're using an integer, right? And so we want it to display as an integer, and it will only display the numbers that we need. Okay, so, this is kind of a weird one. So then why do that? Well, sometimes you have floating point numbers and you don't want to show the decimal points. You just want to show the number, the whole number. And so that's one reason why you would use the first one. If you wanted to, let's say, align it so all your numbers are perhaps left aligned, I'm going to see if I can go up one little zoom level here. That should, well, it helps with this stuff, but it doesn't help with those little boxes. Sorry. But if you notice with this one, it's set to percent 5D, which means we're still doing an integer, but we're occupying 5 digits. And it's right aligned like numbers should be, like in a spreadsheet, for example. And so these 3 characters would be blank and the 24 would be right aligned. With the next one, we do 05D. So it does move the 24 over to the right, but the other places have a 0 placeholder. Kind of weird. I don't know. I don't think that's useful for us. But this might be useful for aligning the numbers, though. The 5D. All right, so we'll have to think about like how big do we want them to be and how much alignment do we want to allow for. Here's another example where you can kind of intermix text within it. So I can say quantity percent 5D, and I get the 3 spaces and the number. And I'm thinking, that might not be too bad. We'll think about that one. That one might be on the table, right? Then we have this one, which is a floating point number. This will display it. If you just use an F, it will display the whole number it has. That's kind of the default, by the way, right? If I do 2F, that's like the monetary format, 2 digits after the number. If I have a number .2F, it'll be 7 characters total, including the decimal point, and 2 after the decimal point. That can also be useful for money. All right. Then we have the S one, which is for strings. So if I just use a plain S, well, it just does a string. So I don't know why you need that one, but there you go. Now, another thing that you can do is you can use a combo or a weird mix, right? I'm not sure how we would apply this one to what we're doing because we're not really doing 2 numbers within the same space, so probably not applicable. But then we have this one where we can format a string, right? 9 spaces, but notice it goes off to the right. Here's one that's a -9 and it stays off to the left. Now I'm thinking, okay, so here's my thinking, is when I look at the book, wait, I guess I'm off that page now, that to align stuff, this one might be useful to get the words off to the left, and then I can use one of these other ones to do the numbers off to the right, right? And if I pick the right values, I shouldn't have to mess with it too much. All right, so this is kind of the basic lay of the land. This is a reference chart with examples. So I'm going to apply this now to the exercise that we had before. And there's a couple things that we're going to do here. So basically, we're just going to work on the print statements. That's what we're doing here on this one, right? This is just straight up alteration of the print statements. The first thing that I'm going to do is I am going to use like a weird combo of these techniques, and I'm going to do multiple wildcards because I have both the names that we're feeding in and the values that we're feeding in. The names are hard coded, string literals, by the way. And then the variable numbers depend on what numbers the user types in, right? Which we can't predict, so we have to accommodate for it. So we're going to experiment, basically. Right, so here's what I'm going to do. I'm going to do this just to the first statement first to test. And then if I like what I'm getting, I'll apply it to the other statements. It's silly to change the whole thing, if the first one doesn't work. So the first thing I'm going to do is I'm going to kind of move some of this stuff around, right? So I'm going to leave this stuff in parentheses, but I'm going to add another set of parentheses around it. All right, so this is kind of weird. And then in front of that original set of parentheses, I'm going to type in, I'm going to have my formatting commands in double quotes, and then I'm going to do a percent sign to indicate I'm feeding wildcards in. Now, when I have more than one wildcard, I separate them with a comma. And then on this side of the wildcard symbol, I am now going to put in my formatting commands. Now, I've done this a few times, so I already know what the best numbers are, and I'm not going to use those. I'm going to intentionally use ones that are a little off, so we have to tweak them, right? So you can see why, like what my method or madness is. So here's what I'm going to do. I'm going to go back to the book. I'm going to look at the exercise again at the output, and then try to do some intelligent guessing, right? I'm looking at all the words that are formatted on the left, and I'm looking at whatever the longest one is, which is difference. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 with the colon. And I probably want a lot for one space. Let's call it 12. So with the colon and the space, that should be enough space for it. So to make that happen as a string, I'm going to start with percent. I'm going to type in -12. Why the minus? Because it makes it left justified. It moves it to the left, right? And then S for string. That's going to take the sum and the colon, right? And put it into a space that's 12 characters wide as a string, right? That's what the first statement does. Then inside these double quotes, I'm going to leave a space, and then I'm going to add the numeric part of it. And so now let's go take a look at some numbers. Longest number I'm seeing here is 5 characters long. That's 22.5. They're counting the period or the decimal point. This one's 3 characters long, but whoever typed this in, well, the two numbers they typed in, by the way, are 25 and 20. How do I know that? Because one's the max and one's the min, right? So that's great for two-digit numbers, two-digit numbers. But what if they type in 2 3-digit numbers or a 5-digit number and a 7-digit number? How do I accommodate for that? You see where I'm going with this, right? And we have to think about this goofy stuff as programmers. That's the geeks that we are, right? All right, so I think 5 characters is not nearly enough. And if this is 5, they also need one extra one, 6, maybe 7, 8, 9. Let's try 7. Let's try like 8 or 9. Something like that seems pretty logical to me. So I'm going to do that by saying percent 9. Let's make it 8 and D for digits. All right, now I'm going to run the program, and I'm going to use some small numbers, then I'm going to run it and use some larger numbers and see. And I'm just looking at the sum right now, not the other ones. The other ones will get converted afterwards. Let's save it. Let's run it. Let's try small numbers first, like 2 and 3. Okay, we'll see where the sum is. It's out here. Okay, well, if everything lines up with that, that could be okay, right? Looks kind of in the ballpark. All right, so I think what I'm going to do now is I'm just going to start converting all the other statements to the same thing, right? So I'm going to copy the technique, wrapping parentheses around everything. And then I'm just going to copy this statement into each one. And so if I was actually clever about this, I would probably copy that and put it here, here. Yes, I see the errors, so don't freak out. Here, here, and here. Except let's Control Z that and put it in front. And then I'm going to have to add a closing parenthesis to each one of these. So once again, this is kind of just an efficiency thing. This is not how you guys might proceed with it, but I kind of think like a spreadsheet person. Like I go up and down the rows and kind of match everything up. And Laura, I see you got your hand up.
Yeah, I'm actually coding along with you, and I fixed the error that I had. The error that I was getting, it was a type error. It says not all arguments converted during string formatting. So I see I didn't have a space in between with the extra percent sign.
Yeah, that makes a lot of sense now.
Okay,
Yeah, totally, totally. Um,
thank you.
all right, so now I put in these same settings for all of these. I already know in advance that the average probably needs the decimal point stuff, but you know what? I'm just going to try it. There's no harm done here in just experimenting. And this is what you should do. You should experiment. So you can use small numbers, but I'm going to use bigger ones this time. So I'm going to use a 2-digit and a 3-digit number. Okay. Okay, that's kind of okay. Let's try something much bigger. Let's try 5-digit number and something bigger. Okay, now it starts to break again. You guys catching that? It's not lining up anymore. So when I get excessively large numbers, not good. So how do I make it so that I can put in larger numbers? Well, I can leave a couple different ways, by the way, right? One way would be that I allot more to the digits. So maybe instead of 8, I do 10. And so if you want, you could just go through here mechanically, fix that. I'm still keeping my eye on the average thing because that one's still going to need to be tweaked, by the way. So here's the 10. And then just to see if that helps, I'm going to try to type in the same numbers I did before. So let's run it. And I'm using the big numbers. I did 1, 2, 3, 4, 5. And 1, 2, 3, 4, 1, 2, 3, 4, 5, 2, 3. All right. Is it any better? It's the answer. No, it's
No,
not. It's not
no.
any better. It is not any better. Totally not.
Mine's
So,
not lining up at all, really.
so kind of interestingly, I'm going to take my longest number here. I'm going to count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 characters. I'm only allotting space for 10. You see the problem? Right. So now I'm going to up that number to 16. So next time I run it, they'll fit. Now, once again, if I wanted to control this, I might tell my user, enter numbers up to and no higher than that number. And that would help me fix the problem because then they wouldn't generate such large output. So let's try it again with the same numbers and see if that fixes the alignment. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 1, 2, 3, 4, 5, 2, 3. Aha. Better, right? I think so. I think it's better. Right. Now, if you don't like how close like this stuff is, I kind of think it's okay. I'm not minding this at all. I'm looking at my last year's or last spring's answer and I used 18 here. I don't see why that was necessary, but that's what I did. All right. The one that we still have to pay a little attention to is the average because the average probably is not exactly this number. Alex, you got a question?
Mine's not lining up at all.
Okay. let me take a look in just a second. Let me just finish off the average thing, and then we'll circle back and do the fixes. All right. With the average, let's look at the book really quick. They're going to 2 decimal places. I'm going to do the same thing. So for the average, instead of doing 16D, I certainly want to get in there, first of all, dot to F, which is 2 floating point digits. But do I then want to allow 16, or do I need to accommodate for the 3 extra characters? See, this is the period and the 2 decimal places need to be added to that mix. So I'm going to change that number to 19 2F. That's my thinking. All right, so let's try this. We're going to do the same very large number, which is 1 2 3 4 5. 1 2 3 4 1 2 3 4 5 2 3. Now I'm memorizing it. That's scary. And there we go. All right, so that's the solution then for this one. All right, so that.
Okay.
All right, so here we go, folks. I am now working on exercise 211, and thank you for my students who reminded me
Also, don't forget to
record. I appreciate that. So you didn't burn me on the save file as, but you did burn me on the record. So, but you know what? The content's all here. Here's the description for the exercise.
Don't forget to share your
Can you
screen.
share your screen?
Oh yeah, that helps too. Right. So now I got like 30 seconds of me like full faced on YouTube, which I don't like, by the way. But it is what it is, you know. Nothing harder than looking at yourself. All right. So here's the program description. It's kind of an interesting one, a practical one, actually. I like this exercise because I think, you know, I don't know. I used to think about this stuff a lot, especially when, you know, I first moved away from home and had to like figure out like how much money would take me a certain distance. And I used to drive these, you know, politely not so great old GM like Oldsmobiles and stuff like that that had terrible gas mileage, and I'd have to think about how much gas I'd put in it to like make it for a week, you know. And I'm not kidding. I'd get like 8-10 miles to the gallon or something, you know, really bad like that. And so when I started getting wiser and buying vehicles that were more efficient, for example, the car, and I always use this car as an example that I would always take to campus for the last, I don't know, 10 years that I've been working there, is this old Volkswagen manual transmission diesel Golf, right? And with a couple of modifications that the previous owner did, it gets like almost 50 mpg, right? So that's insane, right? Compared to most regular cars. It's not even a hybrid, right? It gets better mileage than most hybrids. My clutch broke about a week ago, so I got to either get it fixed or dump it. I'm not really sure, but it's got like 350,000 miles on it, maybe more, you know. But that's how diesels are. They just keep running forever, you know. All right, so here's kind of an interesting little task here. So the task is to write a program that asks the user to input the number of gallons of gas in the tank of your car. So knowing how much fuel your car holds, basically. The fuel efficiency in miles per gallon. And this is something you can Google, by the way. You just take your year or model number and type like, you know, 2006 Toyota Corolla MPG, Google search, and it'll tell you what the mileage is. And then the price of gas per gallon, right? Then print the cost per 100 miles. Like, what does it cost to drive 100 miles in that car? And how far the car can go with the gas in the tank. And by the way, that last little piece is one that you should know whenever you drive through the desert, for example, right? And if you guys have ever driven out west, you sometimes get to a place it's like next gas 145 miles, you know, or something crazy like that. And you should be able to look at your thing and go, I'm half, will I make it? And, you know, if you don't know the answer, then you stop and get gas and pay an exorbitant price, right? But these are really, really good things to know in a vehicle. All right. So we are we're asking the user to input all 3 pieces of these information, right? So we are going to get our inputs from the user to start with. So that's where we start. Get the inputs from the user, right? And we're going to prompt them. So a number of gallons of gas in the tank. All right, so I'm going to call that, and this is what I called it last time. I called it tank amount, right? And I'm going to prompt the user. I'm going to say input, parens, double quotes, enter the fuel capacity of the vehicle. What kind of value are they going to enter? A number.
Numeric.
Yeah, right. So it's going to be a number. So I really should be converting this if I'm going to do math, right? Because otherwise it's going to capture a string. Then the question becomes, do I store it as an integer, a counting number, or do I store it as a floating point number, which gives me more precision? And precision is what we want here. So I'm going to wrap the input statement with a float function, which converts the text that we grab from the keyboard from the user to a floating point number. Chances are they're still going to enter a round number, right? And if you don't know this about your vehicle, you should know how much gas goes into your car. And I say that with all sincerity. If you drive a car, it's kind of one of your responsibilities. If you're not sure, if you open your driver's door and look at the sticker with the VIN number on the door, it usually says it right there. Or run the car to empty and then take it to the gas station and see how much fits. You know, right now I'm driving a Toyota Highlander and that fits 18 gallons.
I don't do that because I cry every time I'm at the pump.
Right? That's funny. But the gas prices have been pretty good lately, Juan. You know, they've been a little bit more affordable than normal.
That's true.
I
But
don't drive.
Well, that solves that problem.
I ride a bicycle all year round.
I bet.
Well, you sound like my children. They do the same thing. And I'm like, what are you going to do when it's 20 below out? Or what are you going to do if your job's across town and it's 20 below out? You're not riding your bike. But and I will say this, my son and my daughter still ride their bike all year round. By the way, my daughter rides her bike to work. My son rides his bike wherever. And then if it's really, really bad, we give him a ride. But you don't, and take this is just an opinion, mind you. But I think without having a driver's license living where we live, you're limiting your financial potential. That's my opinion, right? If you lived in New York City or Chicago or maybe Los Angeles, you can maybe get by without a car, right? In a place like Milwaukee or Racine or Kenosha, I'm sorry, but you need a car. I'd say even in Chicago, you need a car, but that's my opinion. So take it for what it's worth. Everybody's got an opinion, by the way. None of them are right. Right. The other one that we're asked to grab is the MPG, and I'm just going to call it the MPG. We're also going to convert that to a floating point number. In fact, all of what we do is going to be floating point here. We'll put an input statement inside of it with the double quotes, and we're going to prompt for the MPG. Enter the MPG of the vehicle. And, you know, this is kind of me. Once again, this is my style. And I always tell, I want to know in miles per gallon, because there's those people that were like, what's MPG? Right? They don't know. And real frankly, you can never make an assumption with your users that they just know what you're talking about. That is not always the case. So if you're more verbose with your prompts, you get better information from your users. That's my opinion, right? More information is better than less. Right. The other piece of info that we're grabbing is the price. And so with the price, once again, we're going to follow the same format. I'm just going to copy one of these, right? It's just a whole lot of like rigmarole. So I'm going to enter, what are we going to enter on the last one? The cost of a gallon of fuel. All right. Those are our inputs. Grabbing three values, storing them as floating point numbers and three variables. All right. Now, as usual, we're going to do the math, or what we call the processing. So far, it's mostly been math, but We'll get to the point when it's not. And then we got two things to calculate. One is print the cost per 100 miles. All right, well, that's kind of very oddly specific. So I'm going to call my variable that's going to hold the value cost per 100. I could even go farther and say cost per 100 miles, whatever. Cost per 100 works for me. And now I'm going to figure out the equation for determining that. What's the equation for determining that? So if I drive far enough to use 1 gallon of gas, right? So if I use 1 gallon of gas, how do I know how much a gallon of gas costs? Well, I multiply that 1 gallon times the cost of the gas. Easy, right? But when I have an MPG amount, for example, if I have a car that gets 50 miles to the gallon and I drive 100 miles, how many gallons am I using? Well, you should be able to do that off the top of your head, right? 2 gallons, right? So the equation becomes this, right? I'm going to take that 100 miles and I'm going to divide it by the MPG. So for example, if my car gets 25 miles to the gallon, then I'm going to use 4 gallons of fuel to drive that 100 miles. Right? So if I use 4 gallons, then I multiply that by the price. That'll tell me the cost per 100 miles. Because your MPG will go here and the rest will be calculated. All right, so that's the cost per 100. The other thing is to figure out how far of a distance we can travel with the fuel in the tank. And we do that by taking the MPG and multiplying it by whatever fits in the tank. So the tank amount. Don't know how many gallons fit in your car? I know exactly how much fits in every one of my vehicles. You know, now I'm being an auto nerd, right? So my Toyota has 18 gallons. My Volkswagen Golf is 13 gallons. My VW van is 15 gallons. It's really helpful to know. Right? Then you get those like giant pickup trucks where they have like a 25-gallon tank and a 40-gallon reserve, that kind of thing. Or like if you drive a semi truck, like how big are the tanks on those things? Yeah, it's crazy, right? And Juan, if you get upset about like what you're paying at the pump, can you imagine like fueling up a diesel vehicle?
Oh
Right.
yeah. Yeah, a good thing is I only got to use regular, but I do got a truck. My gallon is a 36 gallon tank. So
Yeah, you're cursing at the pump. You're hitting 3 figures probably.
yeah, I'm over $100. Yep.
All right. Next thing we're going to do is we're going to display the output. So here comes the output portion of this. And so I'm going to do a print statement, right? And I'll put in my double quotes. And you know what? I like to start with a blank line. So I'm going to do \n instead of an empty print statement. That's the way I get my blank line. Then I'm going to start my verbiage. I'm going to say, it takes, and I want to round this number because I want to say like how many gallons of fuel, and I want it to be precise, right? So I want to say, okay, dollar percent dot 2F. So we're going to round it. How much value of fuel? So like $50.25 of fuel to drive 100 miles, period. And then we're going to use our percent sign here and the cost per 100. So we will have figured out what it costs to drive 100 miles, and we're going to tell them it costs this much to drive 100 miles. The other calculation. And I'm going to do this output, by the way, in two different ways so you can see it both ways. Is first I'll do the standard Python way, right? Which is to say the vehicle, and I'm sorry about those pop-ups, you guys. I know it blocks your code copying. Can travel. We're going to jump out and do a comma. We're going to type in the distance. We're going to do another comma, back into double quotes, and say miles with the fuel in the tank. So there it is. And let's run it, and then I'll come back and I'll do the string interpolation approach for the final statement. So here comes the run. So once again, I'll use like what I know my real vehicles are. So I'll start with my Toyota. The fuel capacity is 18 gallons, right? The MPG of the vehicle, and I say this politely, on a good day, and I think if I looked it up, it would say higher. On a good day, if I get like 22 to the gallon, and that would probably be highway, I'd be really happy with it, right? So we use 22. And then the cost of a gallon of fuel. All right. So the last time I fueled up was at, I think, Woodman's, and I think I paid $2.89, which is a really good price. So I'm putting in $2.89. So it takes $13.14 worth of fuel to drive 100 miles. The vehicle can travel 396 miles with the fuel in the tank. All right. So here's what I'm going to do now is I'm going to do this last statement. And in fact, here's how I'm going to do it. I'm just going to copy the last statement and paste it back in. And then I'm going to put the letter F in front of the double quotes. I'm going to get rid of the quotes in the middle and the commas in the middle. And then I'm going to wrap curly brackets around the distance output. And then I'm also going to put a comment mark in front of the other print statement. And I'm going to use the new print statement. This is with string interpolation. So I'm going to put that in with string interpolation. Right. I got to like spell it all out in my brain so it comes out clearly. Let's run it. This time I'm going to compare my other vehicle. Fuel capacity is 13 gallons. This is my what year is that? 03 Volkswagen Golf TDI 5-speed manual transmission, right? With a couple of hacks. By the way, there's a couple of hardware hacks and a computer hack in it too. The MPG of the vehicle, I'm going to be conservative and say 48. I've gotten higher. And the cost of a gallon of fuel. Well, the problem is this is diesel. Diesel is more expensive than gasoline often, especially good highway diesel. And I think it's about $3.59, let's go $3.69 a gallon. And let's look at the difference. Even with the higher price fuel, it costs me almost half as much as driving my Toyota. Right. And I can travel 624 miles on a fill up. It's a pretty astounding difference, right? Yeah, it really, really is. Crazy fact, when I first bought this car, I bought it on eBay, sight unseen, right? Just a couple videos and pictures, no kidding, from Florida, because it was not rusty. Flew down there and drove it back. Freaked do it out. He's like, "You're driving it back to Wisconsin?" I'm like, "You better make it." And I only filled up twice on the trip. And I ended up with gas at home. That's crazy, right? All the way from like almost the southern tip of Florida back to Wisconsin. And I only stopped for gas twice.
Yeah, that is crazy.
Yeah, that is crazy efficient. So if you do a lot of driving for work, and I'm just saying this, right? You take that savings. If I'm saving like $6, $7 every time I leave the house, well, hey man, that pays for my quick trick breakfast sandwich or my Starbucks. You know what I mean? And that kind of stuff adds up over time. if you drive a distance. And, when I go from Milwaukee to Racine for work, it takes me almost an hour to get there. It's about an 80-mile round trip. That stuff adds up, right? And that's the kind of stuff you think about. And you know what? Riding a bike is nice because there's no fuel cost, right? But if you choose the right vehicle, it can save you a lot for sure. Juan, you got a question?
Yeah, quick question. On line 24, you got your slash going like this. How did you do that? Because mine goes this way, and then it's
Look above your enter key on your keyboard.
uh-huh. Oh, there. Okay.
Yeah, that's a backslash key.
All right.
Yeah. Welcome to the backslash key. If you've never seen that one before, and you know what? That's okay. It's okay that you've never seen that one before. All right, we have one more exercise to do here, folks. So I'm gonna keep pressing forward. We're working on exercise 232 next. So let's create a new file, do a save as. We'll name it exercise 2_32. Let's go to the book and get the instructions, which I have conveniently copy pasted over here to my other screen. And I'm going to zoom in so we can read them. All right. Right, so our basic directive is to read. Okay, so maybe I need to go to the book because I feel like I'm missing something from the book here. So I'm going to scroll down to exercise 32, which is right here. Okay, so this is, all right, so the following pseudocode describes how a bookstore computes the price of an order from the total price and the number of books that were ordered. This is kind of an interesting little problem. So that's the general lay of the land. And then what we have to do are these tests. So this is the pseudocode. So the pseudocode says, read the total book price and the number of books. That's an input from the user, right? So they're going to input, how many books did you buy? What'd you pay? Then we're going to say, compute the tax, which is 7.5%. Compute the shipping charge of $2 per book. And the price of the order is the sum of the total book price, the tax, and the shipping charge.
Okay.
All right. Seems pretty straight ahead, right? But here's kind of the lay of the land on this, right? This is a pretty simplistic problem, right? Very common kind of like business calculation, right? That you might do for a website or a point of sale system or a spreadsheet or whatever, right? It's applicable to a lot of those scenarios. Now there's some information here that are givens, right? So here's the first couple pieces, and I am, yes, copy pasting these. First, I'm going to declare a couple of constants, right? They're not really constants, right? But the naming convention, when we want something to be implied as a value that doesn't change, is all uppercase with the underscores, right? So this implies the tax rate is not going to change. 7.5% works out to 0.075 numerically. The shipping per book is $2. Notice I'm expressing that as a floating point number. Why? So that when I do my calculations with taxes and whatever, it calculates more accurately as a floating point number. And that would be helpful. So I'll give you guys a moment to type that in. Next thing that we're going to do is we're going to get the inputs from our user. So we're going to do a couple of prompts here. So the first thing that we're told to prompt for is to get the total cost of the books. How much did all your books cost? That's kind of the question, right? So here's that prompt. So I'm going to store it in a variable called book price. I'm doing a standard input and converting it to a floating point number. Why? Because it's a book and it's money, and it might have been $45 even, or it could have been $47.65. Who knows, right? So we want to allow them to be able to enter decimal places into it. Then we're going to prompt them for the number of books purchased. Right? that's going to be a round number. It's going to be a counting number because you don't like buy a book, rip it in half and say, I'll just take this half, please. Right? You're only buying whole books. So we're using an integer in that situation. So these are our two inputs from the user. Then, of course, standard procedure here, right? Input, processing, right? It comes next. And we're asked to do a little bit of math. So if we're going to determine the tax rate or the taxes for the books, right? We're going to take the tax rate and multiply it against the book price, right? So tax equals the tax rate times the book price. That's going to give us the tax. Now, I will say this. I'm just saying it up front. I'm trying not to hotwire the pseudocode, right? Because in this scenario, the shipping charge is not incurring tax. That's not normal, actually, right? It's really, in most places, shipping is considered a service, so you have to tax it. But that's not true in all states, by the way. They vary state by state. So sometimes shipping is taxed, sometimes it's not. Depends on the state. If I really wanted to do an accurate one for Wisconsin, I would apply the taxes to the shipping rate also. I'm just saying. Right. Now we have to determine the shipping cost. So the shipping cost is basically going to be equal to the number of books times the shipping. I'm waiting for my auto type to click in here. Shipping per book. Right. So if I have 2 books, it's going to be $4. If I have 10 books, $20. Then we also have to figure out the total price. And for that one, we're going to take the book price. We're going to add the tax to it. And then we're going to add the shipping to it. That'll give us the total price. Now we're going to get to our output part, folks. Just creating some blank lines here. And once again, I'm going to start with a print statement, and that's a lowercase print. And I'm going to put in my double quotes. And you know what? This time I want 2 blank lines at the beginning of that. Why? Because we're already doing prompts up at the top, right? I want a little space in between the prompts and the output. That's all. So here's what I did last time with this. And so I'm just going to kind of show it to you with a little copy pasting here. I'm going to output a subtotal, which is just going to be, and this is kind of going a little above and beyond, frankly, right? Because ultimately, really what they want to know is the total order. So I could just output total price and be done. And just say total price equals and be done. And a lot of people would do that. Here's what I'm going to tell you as a practical programmer. When you go to a store and you get you buy something and you get a receipt, and even if you don't get a paper receipt and you're just looking at it on a screen, don't you want to see all the details, as many details as possible? Yeah, totally. Right. And this is the kind of stuff where sometimes you have to make this intellectual leap on it. They're not asking for this, but if I was really coding something like this, I would, well, what's the subtotal? How much were the books? Really, ideally you would list the book, the cost, the book, the cost, then a subtotal, then the tax, then add the shipping, and then the total, right? We're not asking how much each book is or what the title is. That's, we could do that though. We actually have the knowledge to do that now, don't we? If you think about it. Absolutely. Then we can do another print statement here. And in the next line, we can say number of books, right? And then I could do you remember the standard Python approach, which is we just display the number of books, like so. what did I break? Oh, I forgot my double quote. That's what it is. Okay, so there we go. So that's the standard Python concatenation technique. If I wanted to switch it to string interpolation, you could do that too. I'm okay with either output mechanism. That's on you. All right. Then we also need to show the sales tax, and all the things that are showing money have that, 2-digit floating point formatting with the wildcard percent sign in the mix. So here's the sales tax. Here's the shipping. And then last time I put the total a little bit farther down. I did 2 blank lines again. And by the way, if I really wanted it to look nice, and I'm just kind of putting it out there, I could use some of the techniques I learned here to make it look all nice. That's doable if you really want to be an overachiever. And by the way, I'm just putting this out there, you should be. That is the kind of stuff you really should do. Like if you were doing this professionally, you would want it to look as great as possible. You want people to go, wow, that looks great. All right, so I'm going to save this. Let's give it a run and let's test it. So enter the total costs of the book. All right, so let's go $250. They're IT books, right? They're expensive. Actually, we got, like in the web program, we have like one Java book that costs, one book costs that much. Yeah, welcome to college life, folks. Enter the number of books. We'll call it 2. So is this output correct? All right, well, now we have to do a little bit of determination here. Subtotal of the books, yeah, 250. How do we know that? Because that's the number we typed in. That's correct, because that's the number we put in. Number of books, 2. That's also correct, because that's the number we put in. The sales tax, 1875. Well, and I don't do this enough in here, or haven't done this enough yet, but whenever we do calculations, we always need to be able to verify those. Correct. Then we're going to take that 1875 and add it to the 250. 2 books shipped at $2 each is $4. Add the $4 to it. It should be 272.75. That's the answer I have, so it's correct. Now it seems really goofy to do it in a calculator when we have Python doing it for us, but you always, and I know I said this before, you always should verify that the math your program is doing is actually correct. If you want this to look pretty, I would take this stuff and align it so it looks pretty. I would go to that trouble. There's a number of ways that you could just do it as it sits right now. Like you could just manually add spaces in, stuff like that. But I would prefer, if you really want it to look nice, that you use techniques such as these, and you can make it look totally on point, like a receipt, like you got out of a cash register. And guess what, folks? People do use Python to write cash register code these days. Somebody's got to code that stuff. It's a job. It's a thing. You can make a living doing it, by the way. And here's a real primitive example of it. But this is, once again, the completed code for exercise 232. I am going to stop the recording here. So this is all the exercises for the week.